Okay, let's get started. Welcome everyone to BCO1916. This is a technical preview of a new solution that we're developing to integrate Site Recovery Manager with stretch storage. We're previewing with you here a new approach to active-active data centers. By way of introductions, my name is Shubhan Lakha-Pragada. I'm a product line manager as part of the Site Recovery Manager team. Been in this role for over 2 years and in the industry for 16 plus years. My co-presenter, Alexei.
Hello, everyone. My name is Alexei Pershin. I'm one of the lead engineers on the SRM project, specifically in the areas related to stretch storage support.
Okay. So this is a technical preview. So the features that we're talking about here are currently under development. This overview should not be treated as a commitment by VMware to develop and GA these capabilities. Features are subject to change. Technical feasibility and market demand will affect final delivery. And please don't include this capability just yet in any contracts. Pricing and packaging is yet to be determined. So we have an action-packed agenda today. I'll start off by an introduction of active-active data centers. I think many of you may be familiar already with this concept. So I'll go through some of this rather quickly. We'll talk about what are the different considerations you have to keep in mind, what are the deployment requirements for active-active data centers. Then we'll talk about the primary solution that is existing today, right, which is active-active VMware stretch clusters. And I'll talk about the benefits and some of the operational considerations you have to keep in mind with stretch clusters. Then we'll introduce this new approach to active-active data centers with SRM. And then I'll hand it off to Alexei to do some demos and share more details on the technical overview. I'm also happy to share with you all that we've been working with IBM and EMC in developing this solution. So a little later on in the presentation, we'll have Carlos and Cody come up on stage and share with you what they're doing to enable this solution. We'll have some Q&A at the end as well. But first, I have a request. Because this is a technical preview, it's really important for us to get your feedback. So we have a short 2-page product-related survey. This is different from the normal survey that you fill out in your mobile apps. Your feedback really helps us in completing the solution. So please take a minute either during the session or after the session to complete this product-related survey. It's really simple to remember, tinyurl.com/our session number, BCO1916. And just one comment, we will not be sharing beta and GA dates in this public forum, but we'll be happy to share them with you separately under NDA. Okay, so let me get started then. So when you're thinking about availability, right, and business continuity for your production applications, there's multiple multi-site topologies that are currently in use, right? SRM supports various topologies already today. The first one is more of a legacy DR scenario where you have a bunker site approach, which is a cold repository of all the production data, right? Maybe it's tape shipping or you're just replicating backups, which is sort of the bunker site approach. The more common scenario with Site Recovery Manager is that second column, which is you have a production site and you've identified a DR site where you might be reusing the compute capacity for test dev workloads, and you might be using SRM with that kind of solution to automate recovery, right? Then there's also an approach that several customers take, which is they have 2 production sites, and they have enough spare compute capacity to fail over the most important critical applications in case of a failure for either site, right? So in SRM, you can set up failover in 2 directions. So all of these are supported. I'm not showing the more complex topologies that are in use by many of you. 3-site solutions, right? Whether it's stretch clusters plus a third DR site, or maybe you're replicating your data to multiple sites, but you're choosing to protect and get orchestrated recovery for one of those legs using Site Recovery Manager, right? But this session is all about this active-active data centers, right? So this is what we are tech previewing here. So in active-active data centers, the primary consideration is continuous availability, right? The primary business objective is you want to minimize the service downtime to as low as possible. And that's why many customers are embracing this active-active data center approach, where wherein it's typically limited to a metro distance. Various vendors and even VMware is trying to stretch that boundary even further, but typically it's limited to metro distance. So like I said, the primary business objectives with an active-active data center approach is that you want to maintain or reduce that service downtime to as low as possible, right? So if you have requirements that under a maintenance of one of those active sites, you don't want to incur any downtime. This type of solution allows you to do that because you can live migrate applications and VMs to the other active site, right? And that's what continuous availability really means. It could be a scenario where you have a data center maintenance coming up, and you don't want to incur any downtime, and you want to do that live migration transparently to application owners, right? And you don't want to go through this lengthy approval process to schedule that downtime. So that's one consideration. The other scenario is disaster avoidance, right? So you know upfront that something bad's going to happen to one of those sites. Maybe it's a hurricane that's headed to one of those sites, or maybe it's a localized flood. And before your data center is completely down, you want to migrate these applications, the most important applications, to the other side. And another key benefit of an active-active data center approach is automated recovery, right? So for those unplanned failure scenarios, whether it's localized failures or site-wide failures, the primary goal is to have very low RTO recovery, right? And technologies like VMware HA have had these capabilities to automatically restart the VMs under failure scenarios, right? So that automated recovery to be able to deal with unplanned failures is really important in this active-active data centers. So at this point, you might be wondering, this is all great, but how does SRM help me in achieving this business objectives, right? And that's really the whole idea here is we're building these same capabilities into Site Recovery Manager, right? And that's what we want to showcase here is how you can achieve the same objectives, right? But also get the benefits of orchestration that Site Recovery Manager has for active-active data centers. So before we get to that SRM piece, let's complete the picture of active-active data centers, right? What do you need in order to build an active-active data center solution? First, you need stretched storage solution, right? Which is basically a storage clustering solution that that has a distributed data mirroring paradigm, where all the IOs are synchronously being written to the other side or being mirrored to the other side. Different vendors use different terminology. But that forms the foundation of this active-active data center approach, and that's what really enables technologies like vMotion to live migrate applications, right? The other key benefit of stretched storage is it gives you that read-write access, right, for these volumes across two data centers. And you also need some kind of reliable mechanism that allows the solution to differentiate between a failure of one of the sites versus an inter-site link failure, right? So different vendors have different solutions. Maybe it's a static expression of a site bias or site preference. Some vendors have quorum devices that are typically deployed in a third site, but it's important to have some kind of tie-break mechanism. And there's many vendors that offer solutions in this space. This list is not exhaustive by any means, but there's EMC VPLEX, IBM SVC, NetApp Metro Cluster, as well as many other partners like HP, Hitachi, and so on. So let's look at what kind of networking solution you need, right, for an active-active data center model. For vMotion to work across these two data centers, you need to have a solution that gives you layer 2 adjacency across the two sites. The options here are you can use any kind of third-party solution, Ethernet over MPLS, Cisco OTV, or VMware NSX is also building a capability to support multi-site NSX. That will support active-active data centers. This is an emerging area for NSX as well. They're actually doing a session, NET 1974. It's happening right now in another room, but I think it'll repeat on Thursday. I encourage you to take a look at that as well. So It's really important to have that layer 2 adjacency for you to be able to do live migration of VMs without having to change that IP address. And that's what really enables to reduce that service downtime, right? There's also some requirements you have to keep in mind for vMotion. 10 milliseconds maximum round trip latency is supported. And for every concurrent VM that is being vMotioned, you need to have 250 megabits per second of bandwidth. So we talked about storage that's required for active-active, and we talked about the networking requirements. Now let's look at how you deploy the ESX environment itself. So far, right, the primary option that you have for active-active data center when it comes to the vSphere clusters is VMware stretch clusters, or VMware Metro stretch clusters is the official name. And this has been out for some time. You know, many customers use this, and it's a great solution, right? And here we are introducing, as a tech preview, a new option where you can use Site Recovery Manager within those two active-active data centers. And I'll show in more detail, right, how the solution looks like. But the whole idea here is that you combine the benefits of continuous availability, right, with the orchestration capabilities of Site Recovery Manager to get a really good solution for active-active. Actually, I want to take a quick poll here, if you don't mind. How many of you are running stretch clusters today? Okay, quite a few of you. And how many of you are using SRM, either with stretch clusters to a third DR site or independently for different workloads? So, okay, many of you. All right, thank you. Okay, so let's get into some more details. So VMware stretch clusters, like I said, it's a great solution. Many customers use it. And you know, it's a solution that allows you to get that continuous availability and reduce that downtime for planned events, right? So the deployment model for this is, you know, you have two metro sites that are using stretch storage, and you have ESX hosts in either site that are added to a single cluster. It's essentially a bigger cluster that's stretched between the two physical sites. And you have a single vCenter that's managing that entire environment. Right? Let's take a look at some of the operational considerations you have to keep in mind with stretch clusters. The first thing is that, you know, remember there's a single vCenter here that's managing your entire active-active data centers. So if you decide to deploy that active or vCenter, let's say in site A, and if that site were to fail, right, you've lost management access to all the other VMs running in the second active site until you've recovered the vCenter. So that's something you have to keep in mind. Of course, HA will continue to operate even in the absence of vCenter, and all your VMs will be restarted. But until the time that you restart the vCenter, DRS pauses, and you won't have management access to the other VMs. The other thing to keep in mind is DRS and high availability are not site aware. Right? So what this means is that HA will restart the VMs in any available host, regardless of which site the hosts are on. Right? And I've seen, you know, many customers, in order to create that site awareness sort of manually, they use, you know, host names or, you know, some kind of rules, right, to even figure out, right, where your hosts are. So the other, I mean, DRS has affinity rules and anti-affinity rules, but it does require a level of operational overhead to manage them, right? So it is possible to get site awareness, but it requires a lot of, you know, complex rules that you need to set. And there's also this decision you have to make of whether you want to set the DRS rule to should rules or must rules, and there's different trade-offs you need to keep in mind. And the last one, but perhaps the most important one, is there is no orchestration or testability with stretch clusters today, right? So what that means is if you want to be assured of the behavior under certain failure conditions, there is no way to test it ahead of time, unlike you can with SRM, right? And also there's other considerations you have to keep in mind. If you're doing vMotions of you know, multiple VMs, you have to sort of manually keep track of which VMs consist of a multi-tier app, and also, you know, the VMs to the stretch volumes relationship, because you want to migrate all the VMs, right, that are sitting on a stretch volume, and then flip the bias once they've been migrated. All those operations you have to do manually today, right? So these are some considerations that you have to keep in mind. Now let's take a look at the SRM approach that we are previewing here. So with this new solution that we are developing, you'll have the option and the capability to deploy stretch storage and stretch networks, just like you do with stretch clusters today. But instead of having a single vSphere cluster that's stretching the two sites, you have localized clusters in either side. And you have two different vCenters, one in each side, and you deploy a site recovery manager in either side. And with this approach, what you're getting is the orchestration capabilities of SRM. But there's also something else here, which is we're leveraging the foundational capability of cross vCenter vMotion, right? So the vMotion team are working on extending vMotion across vCenters, and that's a key capability that we are leveraging here to bring continuous availability, right, and combine it with the orchestration capabilities of SRM. And we'll take a closer look of this. There are some requirements you have to keep in mind for vMotion to work across vCenter servers. I won't go through all of this here, but you'll have these slides for reference later on. Something for you to keep in mind. So a closer look at how the solution looks like, right, with Active-Active Datacenters and SRM. So essentially, you have localized clusters in each site, and by design, HA and DRS will work in that local site, right? And you have stretch storage and stretch network capabilities, and vCenter and SRM deployed at either side. Now, let's take a look at some of the critical failure scenarios and how this solution handles them. So the first scenario here is a localized host failure, right, within a single site. In this scenario, HA basically acts as normal and will restart any failed VMs within that particular site, right? So in this kind of failure scenario, SRM is not in the picture. It's automatically handled by VMware High Availability. Now let's take a look at another scenario. So this is a scenario of proactive, you know ahead of time something bad is going to happen, whether it is a planned maintenance of one of those active sites or a disaster avoidance type of scenario where you know ahead of time that something is going to happen to one of those active sites. So when you do have that luxury of time, right, you can use Site Recovery Manager's planned migration capability. And with this solution, we are enhancing planned migration with vMotion. So you'll have, as Alexi will demonstrate later on, you'll have an option to choose vMotion as one of the capabilities that drives the planned migration. So once you initiate a planned migration with SRM, using the recovery plan, SRM will internally call vMotion to live migrate the VMs based on the priority tiers and the dependencies that you've defined, right? So all of this is handled by SRM. It will also take care of flipping the bias by working with the underlying storage solution. Basically, with this approach, SRM gives you that same orchestration, that same easy button control for continuous availability. Now let's take a look at another failure scenario. This is more of a unplanned failure of a site. If one of those active sites were to go down, you can basically use SRM to do a recovery, right? And the key capability also here is that because SRM has that test capability, you'll be able to simulate, right, any kind of failure and test it ahead of time. And this really allows you to be prepared for site failures in this Active-Active Datacenters. So if there is a failure of one of those sites, you basically use the same recovery plan, whether it's for planned migration, continuous availability, or for site failures, and initiate that failover through SRM, and SRM will basically recover all those VMs from the failed site into the recovery site. And note that here, because there is a separate vCenter at that site, you continue to have access, management access to the VMs that are running in the second site. And another point I want to make here is that when compared to a traditional active application solution, when you use SRM with stretch storage, because those volumes are already accessible, right, at the second site, the recovery time is much lower as well, because SRM and the ESX host don't have to rediscover, right, the LUNs or volumes at the recovery side. So that's another benefit when you compare this solution with the traditional active-passive replication solution. So with that, I'm going to hand it off to Alexei to share more details.
Hello again, everybody. As Shaban outlined, there are two important features that stretch storage brings to SRM. One is for planned failover or disaster avoidance, using stretch vMotion with cross-VC vMotion allows SRM to achieve zero service downtime, not just zero data loss as SRM offers today, but zero service downtime. Nobody will even notice that your VMs are being migrated to the other site. The second important feature of stretch storage that SRM will use, which is the fact that stretch storage is already available on the recovery side, which will lower the recovery time during an unplanned failover if disaster actually already happened. So let's see how it actually works in reality. First, let's talk about what is actually you need to use SRM with stretch storage. Remember what Shaban said about the networking and stretch storage? He kind of lied. There's one thing that he forgot to mention. Yeah, you definitely need stretch storage, and you definitely need stretch network, but you also need a new SRA. The existing SRA that SRM uses today will continue to work with the future version of SRM, but of course, there'll be no stretch storage support. Some partners will write new SRAs that will support the extensions that support stretch storage. This is the SRA that SRM will require to be able to work with stretch storage. Which particular versions of arrays will be supported when this new SRAs will be available? For this, you need to talk to your array vendor. Once you have your SRA, from that point on, the workflow is basically the same as you do in SRM today, which is you install SRM on two sides, you install SRA on both sides, and then you configure array managers on both sides. And once you configure the SRAs and the array managers, then SRM will be able to discover your storage topology, which volumes are stretched, which one has site preference, and things like this. However, SRM will continue not to help you with provisioning of storage. Just as it is today, you will need to provision and control the actual stretch volumes through the array UI, whatever tools that array provides for you. And this is very obviously array specific. So let's get to some demo. So here in this demo, I'm going to just walk you through the first part, the setup part, which is creation of array managers, SRAs, and things like this. In the first part, I go to the site recovery manager, and I go to the list of installed SRAs. And there you will be able to see which SRAs actually support stretch storage and which do not. So like in this case, let me pause here. So notice that at the bottom here, it says stretch storage supported. SRM will tell you whether you have the right SRA or not. And this is where you actually check it. Keep in mind that many array vendors will choose to, most likely will choose to implement a single SRA, both for stretch and non-stretch volumes, which is totally supported by SRM, in which case you really just need to get a new version of SRA. In case that your array vendor requires two SRAs, then you need to install two. Either way is fine with SRM. So once you have the SRA installed, then you need to go and create an array manager. I'm not actually going to create one. There's a very long wizard that you need to enter very array-specific parameters like IP addresses and stuff. I already created one. So once you created one, you will be able to see array pairs, and then you notice that we discovered that some array pairs support stretch storage. And also notice that at the bottom, we will also discover which stretch volumes you have. And we will also tell you which site has the preference if the array supports it. And we also tell you which data stores, local and remote, that this particular stretch volumes maps to. Okay, so with that, let's continue on. The next part, once you configured the array manager and SRAs, next step, how do you configure protection? This is something that will be very different from the SRM you know today. In the existing version of SRM, you have to create separate protection groups for array-based replication or for vSphere replication. In the future version of SRM, we are going with this policy-based everything approach. We will introduce a new type of a protection group, which is called storage profile-based protection group. These protection groups, they're tied to storage profiles. The idea is that once you create a protection group, you specify which profiles that it uses, and anything that shows up in those profiles, VMs or data stores, will be automatically discovered by SRM, will be automatically protected. And really, if you already configured recovery plans and inventory mappings as you do today, then after this, your recovery plan is basically ready to go. So you really, as an SRM administrator, if you configure everything up front, you will be able just to sit and relax and just wait when your boss calls you and say, let's do a failover. One important part here is that this workflow with storage profile protection group requires you to provision VMs with storage profiles. This is something that some people do today, some people don't, but this will be a requirement for stretch storage. And we actually call this DR policy, so to speak. Once you configure a protection group, you can monitor which VMs showed up and which data stores are there. We also will monitor the site preference that assigned to your volumes, and we will warn you if the site preference is not where the VMs are. And this is obviously very dependent on the array. One other note is that for storage profile protection group, you don't need to segregate your stretched versus non-stretched data stores. You can protect all of them in a single protection group. That's perfectly fine, and it's supported. Let's show you a demo. This is actually probably the easiest part of this demo, which is how to create a protection group. First, I'm going to show you that I pre-created a storage profile, and there's already 2 existing VMs on it. So and then I'm going to Site Recovery Manager and going to create a protection group. And when I create a protection group, I really just enter the name and choose a storage profile, and that's it. So you can see I'm selecting the storage profile protection group, and the next stage I am selecting the profile that I had created before. And then once I click Finish, SRM is going to discover automatically which VMs are already in the profiles, and you will see that there's already 2 VMs and 2 consistency groups discovered in that protection group. And obviously, we'll continue monitoring this, and whenever new VMs show up, then we will discover it. So as you can see, let me pause it here. As you can see, there's 2 VMs and 2 VMs, 1 storage profile, and 2 consistency groups. So with that, let's go further. OK, next step. How do you configure recovery? Configuring recovery with stretched storage is basically the same as it is today. You create a recovery plan. You put some protection groups in it. You don't have to segregate stretched, non-stretched vSphere application or array-based replication. You can mix and match. You can create a single recovery plan for everything. It's your choice. For each VM, you can configure things like priority dependencies, and this will be fully supported for stretched VMs for vMotion. When we execute vMotion, for example, we'll honor dependencies and we move VMs in that particular order. You also will be able to assign scripts to VMs, which will be executed, obviously, after the VM is migrated. It can be executed in the VM or on the server where SRM runs. Also, for test failover, which we will not use vMotion, we will power on VMs in the isolated network. You can use the IP customization capability of SRM to run the VMs for test in slightly different environment. Another thing that you will be able to do is you will be able to opt out of vMotion for individual VMs. And at this moment, you should say, wait a minute, why am I wasting money by putting a VM on a very expensive stretch storage and not using vMotion for SRM? The answer is to this is actually, I said at the very beginning, which is there's exactly two benefits of stretch storage when it comes to SRM. One is zero service downtime for planned failover or disaster avoidance, and the second, lower recovery time for disaster failover. Some VMs may not survive vMotion. If the VM is way too big, way too busy, and your network is too far, too thin, vMotion may not complete. So in this case, you may choose to turn off vMotion and follow through normal shutdown restart cycle for that VM. However, you still use the benefit of lower recovery time by placing the VM on stretch storage. And this is why you would want to do this. I'm not going to show you a demo of recovery plan because it's a really easy part. Next step, once you configured everything, so let's talk about the planned migration or planned failover disaster avoidance. The key part here is that both sites are operational when you initiate this thing. When SRM starts a recovery plan in planned migration mode, the first thing it's going to do is going to ask the array to move the site preference to the recovery site. And after this, it's going to go through the vMotion cycle of all the VMs that you configured for vMotion. And only after all the vMotions are completed, after this, we're going to go through the shutdown and do all the things that we do for VMs that are not residing on stretch storage. And just as I said before, SRM will use dependencies and priorities in this case. Another important feature of SRM is the ability to rerun a recovery plan. Usually, when it comes to existing SRM, most cases a plan failover succeeds. If there are some errors, then it's usually an exception that can be fixed, and you need to rerun the recovery plan. When it comes to vMotion, it's not as simple. The problem is that vMotion is very sensitive to environment, and it's not something that you can configure up front and forget about it. As Shaban mentioned, there's latency requirements that needs to be met. If your network is suddenly busy, then vMotion may not work. If the VM is too busy, vMotion may not converge. So if anything like this happens, SRM will actually going to stop and tell you that some vMotions failed. At this point, you have an option to fix the issues and rerun the recovery plan with vMotion turned on. And SRM will pick up where it left off and retry vMotions that failed, and vMotion succeeded, obviously will be left as is. However, sooner or later, you will come to a point where you cannot fix any more vMotion issues, or you deem that it's very expensive or unreasonable to fix vMotion issues at this point. It may be whatever it is. Maybe the hosts are incompatible on the recovery site, and provisioning compatible hosts just going to take a month, and you only have a few hours before hurricane hits you. So in this case, you have an option of telling SRM, just run the plan failover as is, do not use vMotion, even if VM can be migrated using vMotion to the recovery site. In which case, SRM will happily shut down the VM, and then will restart the VM on the recovery site later. Obviously, in this case, there will be a service downtime, but at least you will have no data loss because you're still running a planned failover. Another important consideration when it comes to vMotion is the actual vMotion time. Nobody can tell you up front that a vMotion of this given VM at this given moment in time will take 1 hour. It's just impossible. It may take 10 minutes, it can take 10 hours. It depends on so many factors that are very hard to estimate. Imagine that you're in a situation where you're in Texas and you know that you have 8 hours before hurricane hits you. So you start a plan failover to avoid the hurricane, and then you're sitting through it and you realize that your vMotion has taken too long. So what do you do in this case? Obviously, you can just let hurricane hit you and then recover from a disaster after the fact. But this obviously has some negative effects on your services, and you may actually suffer some data loss, because if your data center goes down, you don't know what happens with replication at that point. Ideally, in this situation, you should have already run a test failover. And our answer to this particular problem is that you run a test failover up front maybe a month ago, and you use the time that it takes to run a test failover to estimate how long it actually takes you to recover VMs on the recovery side, assuming that there is no production site. And let's say your test failover takes you 1 hour. Then to be safe, you double it up and you say 2 hours, that's how long it takes you to recover everything on the recovery side without using vMotion. So in this example, with the hurricane hitting you in 8 hours, you're sitting there and then you wait for all the vMotion to work for 6 hours. The moment you go 2 hours before the hurricane, you just cancel recovery plan and rerun without vMotion. It will be some service loss in this case for VMs that haven't been migrated yet, but at least no data loss. So enough words at this point. Let's show you a demo. In this demo, I already have the environment that I set up before, and I pre-created a recovery plan, and I'm going to execute it with both sides running. So let me walk to the recovery plan. As you can see, it's already pre-configured. And here, I'm going to pause for a second just to demonstrate this. Notice that when you choose the plan migration button, there is one more button here called Enable vMotion of eligible VMs. This is your control point of whether or not to run a recovery plan with vMotion turned on. If you turn it on, SRM will do vMotion for VMs it can. And if you don't turn it off, even VMs residing on stretch storage will be shut down just like any other VM. And now, in this case, I'm going to say use vMotion, and then just click the finish button. And at this point, recovery plan is going to run and do its stuff. And while it's doing this, I am going to go to the production side, to the actual vCenter UI. And I'm going to look at the cluster where the VMs used to reside. Well, they're probably still residing. And as you can see, we'll get to that point. I'm going to show you that there's no actually shutdown tasks being executed on the cluster. You only see that there's vMotion tasks being done on it. And this is expected behavior because we asked SRM to use vMotion. And notice that there's no more VMs here. They've been migrated to the recovery side. And I'm going to go to the recovery side vCenter, and I'm going to look at the cluster there. And just as expected, you will not see any power on tasks or anything like this. There will be some host rescans, and pretty much that's it. So let me get to that. So as you can see, there's just host rescans. There's no power ons. And then after this, I'm going to show you the VMs running there. And just as expected, there will be 2 VMs, and both of them are already powered on, because vMotion leaves them running. Now I'm going to come back to the SRM UI and look at the recovery plan as it's still running. It's probably already completed. So yeah, it's about to be completed. OK, now it's completed. And I'm going to pause here for a second. So you see there's this steps for migration. This is where you would see the status of vMotion for each VM. And then I'm going to go to the bottom of the recovery plan, where you would normally see things like surfacing storage, rescanning hosts, and doing these things. And you will notice that we didn't import VMs, and we didn't power on. You see the steps are actually skipped. Let me pause it here. So, yeah, okay, here. So as you can see, there is no import is skipped, and then power on was skipped as well. If you notice, there's lots of warnings, and there's some fix missed there. This is actually the reason why this session is called Tech Preview, as opposed to what's new in SRM 2014. So this is work in progress. So, but at least I can show you vMotion today. When you will actually be able to put your hands on this version of SRM, that's Shoban said, NDA. Sorry, guys. So at this point, the failover is done. So that's it. Now let's go to the next step, which is unplanned failover. As I said earlier, the main advantage of stretch storage in unplanned failover is the shorter RTO. You usually execute an unplanned failover in cases where production site is already down or mostly down. In this case, SRM is not going to do vMotion, obviously, because production site is not there anymore. We will restart the VMs just as we do today. We will honor the dependencies, the priority groups across all the VMs, so you will know that your services will show up the way that you expect them to show up. We also will coordinate with the array to make sure that whatever is left over at the production site is not going to affect your recovery. And the problem here is that if you somehow have some ESXs running and then some VMs are still running there, but from your perspective as the administrator, that site is dead. But the VMs are still running, the storage is still happily replicating stuff across sites, then you won't be able to power on the VM. So SRM failover will fail. So in this case, we ask the array to help us isolate the recovery site from production site, and we will happily recover. This is, by the way, this is array-specific feature. You really need to ask your array vendor to see whether they support this or not. And then I'm going to show you some demo of this.
So the other thing to add here is that, we talked about when we reviewed stretch clusters, one of the primary benefits is that automated failover, right? So we're looking to add that same capability to SRM as well, where when you're using stretch storage, you can initiate this unplanned failover automatically through either an external system that can reliably detect that there is, in fact, a site failure and not just a split brain. And that would basically complete the picture of getting that very low RTO and automated recovery.
Right. So now I'm going to execute a failover on the same recovery plan. It's the same setup, so it's not really after that plan failover. It's the same setup as before. Here, I'm going to pause for a second. Okay, let me go a little bit further. So notice here that I'm going to choose disaster recovery. And also I'm going to choose this magic bottom at the bottom. It says force recovery site operations only. I'm somewhat cheating here. I didn't actually shut down my production site. But SRM has the capability to execute unplanned failover without even trying to talk to the production site, because you never know what kind of timeouts you get. You just want to recover right now, whatever the cost is. So, and that's what I'm doing right now. Once I click the finish button, the recovery plan is going to start running. And I'm going to go to the vCenter at the recovery site. I'm going to look at the VMs there. So let's pause for a second. So notice that we're skipping all the steps at the production site, just as you would expect from unplanned failover. And then on the recovery side, you will see that in the target cluster where I am recovering VMs to, the VMs will be surfaced and they will be powered on. So let's get there. So, and as you expect, you see there's tasks here to rescan hosts. And then there's registering the VMs, and then there's already a power on for one of the VMs. And then in the list of VMs, as you can see, one VM is already running. The other one is about to be powered on. So I'm going to refresh. And as you can see, both VMs are now running. Now let's go back to the recovery plan, and it's already completed. And just as I said, a lot of steps on the production side were skipped. And then this time, as you can see, there's power on was actually success, and the import was actually success. So at that point, the unplanned failover is done. So let's talk about a couple of other use cases that SRM supports. First one is a test failover. A test failover in SRM we use to verify that you are ready to execute a recovery. You will be able to do this for stretch storage as well. However, this will not be your test of our planned failover, because we cannot execute a vMotion in a sort of test mode. If you do a vMotion, VM is moved. Then it's no longer non-disruptive test anymore. It's an actual failover. So what we will do is that we will run the compatibility checks on your hosts to the extent that we can, but other than that, we won't do the actual vMotion. We will, however, power on VMs that reside on strange storage. We will do IP customization if you asked us to. And we will, as I said, we will honor the dependencies and run the scripts and everything we do today. This feature will be array specific, as I said earlier, so you should ask your array vendor to see if they support creating writable snapshots of stretched volumes. As I mentioned earlier, we consider a test failover as a tool to measure the time you need to run an unplanned failover. So pay attention to how long it takes you, because it will save you should a hurricane come to your data center. Another workflow that exists in OSRM, which is reprotect and failback. This will be supported as well for stretched volumes. What we will do is that we will ask the array to repair a replication if it was damaged as part of the unplanned failover due to the isolation work or whatever else array had to do during the unplanned failover. And effectively, after reprotect is done, we will reverse the roles of sites, which used to be your recovery site becomes protected sites. We'll make sure that the site preference on the stretched volumes moves to that site. And after this, everything is up and running. If you want to go back to your former protected sites, after you executed reprotect, you need to execute a failover, and hopefully you did the test failover first. And at that, I'm going to pass the baton to Carlos from IBM.
So, as I said, my name is Carlos Fuente. I'm the chief architect for the SVC and Storewise programs, heading up the development teams which are based mostly in the UK and the south of England, but also have presence worldwide. I'm going to talk a little bit about the work we're doing with VMware on supporting SRM with stretch cluster for SVC specifically, and why we think that's important for your enterprise and getting the benefits of stretched storage. So just by way of introduction, you're all familiar with VMware and the capability it gives you in terms of virtualizing your physical servers and providing you a lot more flexibility in managing the deployment of your workloads across physical resources and hiding changes you make to those physical resources. SVC for storage does very much the same job in terms of separating the logical assignment of storage from the physical storage controllers that present that physical storage, and gives you flexibility to change the storage, to manage planned outages, to reassign storage, to do commissioning and decommissioning. And this technology has been with customers for 11 years now. We have some 40,000 nodes installed worldwide, and a lot of customers have benefited from the virtualization technology for their storage, much the same as they have from using VMware and other servers on top of SVC. This is the basis of the stretched storage solution we provide with SVC, and about 5 years ago, we put together this capability to take an SVC cluster and position it across 2 sites with a copy of storage in each of the 2 sites. So this picture very much resembles the one that Shoban shared earlier on in the presentation. In terms of the particular capabilities of SVC here that are important when considering a stretched storage solution, SVC provides a single point of management. It's important to think about the whole management stack when you're trying to plan a stretched cluster installation. And using SVC, you get a single point of management for configuring, doing all your day-to-day admin tasks related to the storage provisioning and providing storage up to your VM environment, as well as any other servers that you might have. SVC has a lot of other function that you might be able to benefit from, including remote replication, to provide out-of-region disaster recovery if that's important to you, using real-time compression to reduce the cost of your storage and maybe half the capacity you have to install to support your workloads, and a bunch of other functions that do support SSD. Another important consideration, SVC has a very wide storage interop matrix. So we have 250 plus storage vendors and storage devices that we support behind SVC. So you don't have to change your storage infrastructure. You can reuse existing investment and get the benefits of stretched storage. And either keep with the same vendor strategy or change your vendor strategy. You get the flexibility that using virtualization for storage provides. So we also provide active-active quorum management with a third site. By preference, we have a quorum device and a third site. So this is an important piece to make sure that any difficult inter-site link failure is handled automatically. So the whole solution doesn't require any host software to orchestrate the failure, and many small-scale problems, faults in the infrastructure, in the arrays, in the networking, storage networking, are handled automatically, either with error recovery in the SVC layer, or possibly error recovery in the VMware multipathing driver to reroute IOs and make many of the storage failures completely transparent to the applications. You then get the benefits of, let's say, a stretched vSphere solution that lets you use vMotion to provide planned switches between the two sites and move workload between the two sites. And then we start to get into the benefits for larger scale problems that SRM can start to help you solve. So the SRM is really looking to help you manage those more complex, larger scale failures. The planned site failures where you're concerned with the complexity of migrating a whole set of servers, and a simple vMotion by vMotion of a complex environment might not be successful. And also the unplanned site failure, which is still fundamentally a difficult thing to do. So I'm just going to try and emphasize a little more the difficulty of the unplanned site failure and the value of SRM when combined with stretched storage. When you have a site failure and you're faced with doing an unplanned recovery of the other site, the orchestration for restarting the servers is still a complex job. It's still something you need to give consideration for. If this is something that you want your stretched storage to let you survive, you still need to do the appropriate planning of the actual recovery process and use the SRM technology to provide the recovery plans. You need to test and plan to test and develop the resources to test that infrastructure. And you also need to review all the other processes in your business, in your environment, that support a DR invocation, including things like how your personnel will get on site and get able to access the infrastructure. So those problems don't go away, but active-active storage with SRM does make the solution much more affordable. There are enterprise-class clients out there who deployed classic DR synchronous replication solutions, and faced with a critical site failure, do not fail over because they don't have confidence in their DR plan will actually let them run production, and they don't know how to fail back. By using SRM to manage your day-to-day activity, your planned failover activity, you get confidence in the recovery plan, confidence in the infrastructure's ability to support a recovery. And so if, fingers crossed not, but if you ever face that unplanned failure, the SRM technology means you will be confident to invoke the recovery plan that you've used already, you've tested already, and be confident that your recovery will work. Thank you very much. I'll now hand over to Cody from EMC. Thank you.
All right. I apologize, I don't have a British accent, so it's not going to be quite as interesting. My name is Cody Garvin. I work for EMC. I work on the VPLEX product as a product manager. I just want to go over a couple quick things. We don't have a lot of time. I want to have some questions at the end, so I'll try to be very, very brief. If I gloss over anything too quickly, please go down to the EMC booth on the show floor and ask questions, or find me after. So, VPLEX, like SVC, is a storage virtualization product, right? We take arrays, LUNs coming up from arrays, abstract those LUNs, present it up to your hosts. In VMware's case, your ESX servers. And what we primarily see is a stretched metro cluster deployment, like we discussed earlier, where you have your VMware cluster stretched between 2 data centers, and everything that is great about VMware sort of works naturally between these 2 data centers. VMware HA, DRS, FT if it's within the requirements, and vMotion. By providing the sort of active-active storage layer that VPLEX and SVC also provides, we're able to get what we call instant vMotion. You don't have to do a storage vMotion when you're transferring a VM from one data center to another, right? The data is already there. VPLEX provides a local copy, keeps those copies in sync. So when you do a vMotion, all you're doing is transferring memory, right? This is what we have today, right? VPLEX gives you a couple of extra benefits here. For your site connectivity, you can choose IP connectivity. You can use FC connectivity. You don't necessarily need the cross-connect that was shown on some of the previous slides for FC connectivity. We have a no single point of failure architecture, which means if you lose any component of VPLEX on a VPLEX cluster, your data remains available, your VMs continue to run, you don't have any downtime. And for our, we call it a witness, our quorum site, our third site, that's actually a lightweight VM that works in anything from VM Workstation, VM Player, to another ESX cluster. And it just communicates directly with the VPLEX clusters at either site and coordinates for any sort of site failure or network connectivity failure. So if you lose network connection between your sites, they don't know necessarily without witness who should have the data, where the VMs are running, and that sort of thing. When you add witness in, they're able to locate your data at the data center where your VM was running. So if you were running a VM in data center A, and you lose connectivity between your 2 data centers, that VM continues to run at data center A because that's the best location for it, right? But what we're here to talk about today is SRM, right? So what we're looking at here is a similar sort of setup. You have 2 data centers. You have VPLEX providing stretched storage, right? But you have 2 separate clusters, 2 separate vCenters, 2 separate instances of SRM. But you have a lot of the same capabilities. You have instant vMotion, this time coordinated through SRM, right? You have the ability to fail over workloads. You can manually load balance by using vMotion to shift workloads between sites, right? But then you also have the extra benefits of the test and the unplanned failovers and recovery, right? And of course, because it's VPLEX and nothing has changed on the VPLEX side, you have the same sort of capabilities of the third site witness and the no single point of failure, choice of connectivity, that sort of thing, right? Well, I will say that obviously, since this is tech preview, we can't do this today. But we can do the first one today. And we can do this one today. And this is sort of a hybrid of the 2 solutions, right? Where you have a 3-site solution with a stretched metro cluster between 2 metro data centers. And then you have a third site, which has a DR copy. And actually, this is a joint VPLEX recover point solution. We call this Metro Point. And so you have all the benefits of your stretched metro cluster, your ability to do HA between data centers, instant vMotion, DRS, load balancing between your 2 metro sites. And that third site can be synchronous distance, asynchronous distance. For instance, you could have 2 data centers in Napa and a data center in Chicago, and if there was an earthquake, hypothetically, in Napa, you'd be able to recover via SRM to your third DR site via your recover point integration with SRM. So this is something that also capable of doing today. If you have more questions about this, I suggest hitting the booth and asking about it. I think you have some summary words.
Okay, so I think we have a few minutes for Q&A. So just in summary, SRM will be a great solution for active-active data centers when this is fully available. SRM is not just a DR product. You can use SRM for continuous availability as well, right? So let's go to Q&A. I'll leave this slide up here for you to fill out the survey. Go ahead, please.
I think You should probably walk up to a mic so
if you
that
could please
everybody
walk,
can
yeah.
see her.
I didn't leave much time for Q&A.
Do I have to introduce myself?
We'll stick around if you guys want to talk offline as well.
Okay,
Go
so
ahead, please.
I was wondering, in the beginning, you put up some parameters that for this.
Okay.
So I was
right.
wondering real quick, one of them is 100 kilometers or 60 miles is the maximum distance between the data centers. So why is that? Is that because you don't think you can get a
So,
latency shorter than that?
Yeah, I think that, so that's a vMotion requirement that vMotion is supported up to a maximum of 10 milliseconds, right?
It's an approximation of distance given
right.
the 10 millisecond latency requirement.
Synchronous arrays, the two arrays have to be synchronous. The link between the arrays has to be synchronous. You mentioned that
Thank you.
in the beginning. And so I'm not a fan of synchronous. I'm a fan of asynchronous because synchronous, your production array only runs as fast as the one on the other side of the slow link. So I have a 16 gig fiber channel SAN, but I have some sort of link between the two. You did mention that in the beginning. So
The answer to this is that your stretch storage solution, it may be synchronous, may be asynchronous. This is really a feature of the array. Some arrays do fully synchronous, some arrays do asynchronous.
The demo will be recorded.
so whatever my array will do, but it was on one of the slides. And
VMworld.
The truth is that SRM does not care.
does not care.
Right. SRM will work just fine. We actually will do some extra things to sync the storage so that the asynchronous stuff doesn't get lost on the production side.